Okay, so we're going to start shifting our attention to the coordinate plane. We're going to start putting angles on the coordinate plane and looking at the trig functions on there. So we're going to put angles, like I said, on the coordinate plane, and we're going to put them most of the time in standard form, which means one of the rays is going to be the x-axis, the positive x-axis. The vertex is at the origin, and the other ray is somewhere else in the coordinate plane. All right, the ray on the x-axis is called the initial side. That's the start, okay? We start on the positive x-axis, so this is the initial side. The other ray is called the terminal side. That's where the angle stops. So basically we start on the positive x-axis and we rotate until we get to the terminal side. If we are going counterclockwise, that is going to give us positive angle measures. If we go clockwise, if we go the other way, that's going to give us negative angle measures. And as you would already know, if you go one way all the way around, you will have gone 360 degrees. So that means that each quadrant gives us 90 degrees. So 90, 180, 270, 360. The other way would be the negative direction. Okay? So you're going to tell us to sketch an angle in standard position. That means the initial side is going to be on the x-axis. So we're going to draw that ray there. 75 degrees. That's going to be not quite 90, right? We don't have to be super exact here. We just know that it's going to be pretty close to 90. We draw an arrow to show we were going that way, okay? Negative 160 degrees is going to go in the negative direction. Well, it's more than negative 90. If we went another quadrant, we'd be at negative 180. So we're going to back it up some. So we're going to have initial side, and then we're going to go not quite to the 180, and we're going to say this is negative 160 degrees. Now, 430 degrees, that's more than 360, right? So that's all the way around in the positive direction. And then, 70 degrees more, so not quite up here. So here's what we do. We show that we go all the way around and then a little more, right? So we have our initial side, and then our terminal side is here. So it actually looks like an acute angle, but this little loop-de-loo that we draw here, that shows that we went all the way around and then some extra. So that shows a positive 430 degrees. Okay, next we want to know about coterminal angles. Coterminal angles, they're in standard position, so they start on that positive x-axis, and they have the same terminal side, but one is going to be more rotations than the other, okay? So if I have a 65 degree angle, that is what, about right here? That's about 65 degrees. Well, what other angles would end in that same spot, okay? So if we start here and we go all the way around and then in there, if we went all the way and then there, that'd be in the positive direction. So that'd be what, 360 plus 65? Which is 425 degrees. So one angle that is coterminal with 65 is 425. That's all the way around. 360 plus that 65 gives us 425. Well, what if we went the negative direction? What if we started here and we went this direction? That would be, if we'd gone all the way around, would be negative 360, right? But we haven't gone this 65, so I'm going to say 360 minus 65. If we go negative 295 degrees, that is coterminal. So those angles are coterminal with 65. They look the same, but the difference is one of them is in the negative direction, one went more than one rotation, okay? All right, 540 degrees. Well, let's see what that would look like just by itself. So what is that? 360, it's going to be less than 2 revolutions, right? So 540 degrees is 360 plus another 180, right? So it is on the negative y-axis. There's 540 degrees, right? Now, what does that look like? That looks like a straight line. So one angle in the positive direction that's coterminal with it is 180 degrees. If we go positive 180 degrees, we end up in the same spot. If we go negative direction, negative 180 degrees, we end up in the same spot. So I try to find these out by drawing. There are other ways to do it. Basically, you are adding or subtracting some multiple of 360, but whatever way works for you. All right, what they're going to do next is they're going to give us a point. Here it's 5, -2. They're going to tell us it's on the terminal side of an angle in standard form, and we've got to find all the trig functions, okay? So if I go over 5 and down 2, I end up right here, right? 5, -2. And when I do that, this makes a little right angle, and then I make a right triangle, right? Well, here's the angle we formed. That's our angle right there, okay? And so what we're doing is we're going to find all the trig functions of that angle. So we need to know some values. Well, this length, this leg has length 5, right? Now, this leg has length 2, but it's negative. It went down, and that's important. So we need to know that that's a -2. So we need to find the hypotenuse. So we're going to use Pythagorean theorem here. We're going to say 5 squared plus 2 squared equals c squared. And we get that the hypotenuse is the square root of 29. So this is the square root of 29. So now we're going to find all our trig functions based on this. So sine. Sine is what? Sine is opposite. So if this is my angle, here's the angle I formed right here, this little angle, it's negative, and it's in the 4th quadrant. Opposite is -2 over hypotenuse is the square root of 29. I'm going to have to rationalize, and I get -2 root 29 over 29, okay? That's kind of hard to read. All right, cosine is adjacent. The adjacent angle, or adjacent leg, to that angle is 5. 5 over hypotenuse, square root of 29. We're going to rationalize. And we're going to get 5 root 29 over 29. Tangent of this angle is the opposite, -2, over the adjacent leg, which is 5, and we get -2/5, and we don't have to do anything with that, okay? Cosecant. Remember, cosecant is the reciprocal of sine. And what we want to do so that we don't have to rationalize again, take what we started with, which was -2 over root 29, and just take the reciprocal of that, and we're going to get root 29 over -2, okay? You could start with this over here, but that's ugly. Start with where you started and flip it, and then you've got the reciprocal function. Secant, we're going to take the reciprocal of 5 over root 29 and get root 29 over 5. Cotangent, we're going to take the reciprocal of -2/5, and we're going to get -5/2. Okay, this next one's very similar. They give us a square root for one of the values, but that's okay. +3, so I'm going to go, first I'm going to get a pen. I'm going to go over 3. Square root of 5, that's a little more than the square root of 2, right? So it's like up 2. Doesn't really matter where it is as long as we know that it is root 5. So you're going to draw your triangle in, and I want you to find the hypotenuse, and then I want you to find your 6 trig functions. When you get done, turn the video back on and check your work. All right, here's what I got. Sine was opposite over hypotenuse. When I rationalized the denominator, I got root 70 over 14. Cosine adjacent over hypotenuse, 3 root 14 over 14. When I rationalized tangent opposite over adjacent, root 5 over 3. This one, to find cosecant, there wasn't a pretty way to do it, so I took the reciprocal of the first one, rationalized, got root 70 over 3. Secant was root 14 over 3, and cotangent 3 root 5 over 5.